Welcome to Filtration Matters, the regular podcast from BOFA International, a world leader in portable fume and dust extraction. In this series, we'll be exploring how innovations in filtration and system design are helping to improve productivity across multiple industry sectors, including in laser, 3D printing, and electronics. BOFA experts talk about how advances in extraction technology are helping to optimize manufacturing processes and product quality, while at the same time contributing to a clean, healthy working environment. Our guest today is Geoff Sagar, a product manager at BOFA with specialist expertise in laser-generated fume and particulate extraction. In this podcast, Geoff discusses the remarkable flexibility of laser technology in manufacturing processes. Think of it as akin to a Swiss Army knife for industry. We'll be taking a look at the evolution of laser technology and its application across multiple sectors, from food and drink to fashion, packaging, and more. We'll also be talking about why fume extraction is not only good for enabling healthy work environments, but is also a positive contributor to productivity. So welcome, Geoff.
Thanks, Phil.
So before we talk about lasers, perhaps you can tell us something about your role at BOFA.
Yes, certainly. I joined BOFA about 3.5 years ago, and I originally joined in the sales department as a business development manager, where I was working with various customers in the laser industry, looking at new applications, looking at ways that we can provide product solutions to their needs in laser marking, laser coding, and cutting and engraving, and other applications. And in terms of my role before that, I was originally a mechanical engineer, qualified as a mechanical engineer, and my very first job after qualification actually was developing a laser-based measurement system which used diode lasers, which at that time were in their infancy, for making high accuracy measurements on steel bars. So that was my first experience of lasers.
Most of us will have a picture of lasering in our mind's eye. So perhaps you can walk us through the evolution of the technology and the range of materials now being worked when it comes to industrial processes?
Yes, certainly. Lasering has been around now for 60 years. It was the 60th anniversary a couple of years ago, I think, of the development of the first laser. And as the product and as the applications have been developed, the technology has been migrated into a number of different applications and industries, and becoming more and more commonplace and regularly used. We will come across lasers in our everyday life, in the DVD drives of our computers, or the CD drives in our entertainment systems or gaming consoles. Every household has a number of lasers in it without realizing. But the higher power lasers are used in industry for cutting and marking and engraving and processing products to a very high degree of accuracy and precision, and enabling processes and production techniques to be engaged where perhaps otherwise it may have been traditionally a more onerous or slow process. In terms of materials that we're looking at, practically any material can be lasered. We have a particular interest, we here at BOFA have a particular interest in the materials that our customers are using, because we need to know the types of fumes and the types of chemicals which will be coming off those products when they're lasered, so we have a good understanding of the specific types of filter that we should apply to safely contain and capture that fume and particulate. But in terms of materials, it ranges from metals for marking, for either traceability or coding applications, marking for decorative or corporate identity applications, plastics such as PVC, acrylic, perspex, nylon, any plastic like that, often used in laser cutting applications for making items, making objects, and woods like MDF and plywood and other wood-based products used again in cutting applications for making ornate and intricate products very, very quickly and very accurately.
So maybe before we go any further, perhaps you could explain how a laser actually works.
So the laser itself or the laser light itself is single wavelength, very, very high power, very high intensity, and that enables it to be used in very high precision applications, whether it's reading the optical data off a disc, or in the cases that we're dealing with, focusing down to apply a mark or a code onto a product.
So you've mentioned different applications there. So where might we find lasers actually delivering value to manufacturers?
So the use of lasers in manufacturing is very, very widespread, and it can be either they're typically used either in processes where they're replacing a cutting or engraving application. So what used to be a mechanical milling operation or a mechanical marking operation can now be done very quickly and very accurately and very repeatably by a laser. And this will leave an indelible mark on the surface of the product. So we're either burning off or removing a layer of coating, which may be paint, or it may be a plastic film or something like that to leave a mark, or it may be actually ablating the surface of the product itself, whether that be plastic or metal, to leave a permanent mark. And this is why it's become something, in terms of a process, it's become very popular in certain industries where the requirement to leave an indelible mark is very, very important. So a laser marked component won't have that mark washed off or worn off by wear and tear or by cleaning. In some cases, using lasers to replace other technology which may have been used in the past. So for PCB manufacturing, for example, a lot of PCBs now where they traditionally would have been cut to give the external dimensions and then drilled to give the actual holes where cables or connector pins would be fitted. These can now be cut by laser, so a single laser will make the profile of the PCB and also effectively drill the holes in the board as well. We've got a lot of marking applications in fast-moving consumer goods, where marking and coding applications on product lines and production lines, this previously would have been something that, and it still is something which can be inkjet coded or marked by some printed mark. But increasingly, we're finding that customers and end users are moving more over to laser applications and laser technology in order to give a mark which is much more robust and much more indelible throughout the life of the product. So if the product goes through a washing process, or if the product goes through some elements of manual handling or robust handling, or automated handling, then that can often cause a printed mark to be either damaged or removed completely. But a laser mark, that by virtue of the way it's put on, will be much more robust.
So what role does BOFA fume and dust extraction play in this laser world?
Well, we work very closely with those manufacturers of laser systems and the laser OEMs, and we're working with them to ensure that the applications that they're applying the laser to is adequately controlled and managed in terms of fume capture and fume collection. So when a laser is used to remove the surface of a product or mark the surface of a product, often particulate will be released or chemical changes may occur which produce chemicals, and that's all what we refer to as laser fume, and that's what we have to capture and contain safely. So what we do is we're working with those laser manufacturers to make sure that the applications that they are applying the lasers to are adequately controlled in terms of fume management. So if the application is in a highly populated area, for example, if it's a production line with operators, or if it's a customization set up in maybe a shop or a print shop, where members of the public may be looking at their items being customized or produced, which is often happening these days. We ensure that we're capturing the fume and making sure that it's a safe environment for everyone to be in. Also, we've got to make sure that the laser itself can be kept clean and clear of any particulate. Production lines that are operating 24/7, they need to be kept clear and clean so that the laser will stay operational. And so our systems are keeping the laser and the laser optics and also the production area clean of dust buildup so that there isn't any long-term production issue there. But we've also got, for the more unusual applications, we also have an applications engineering department here. We've got qualified chemical engineers, we've got qualified process engineers who will be able to look at an application from first principles, if you like, and work out from the material which is being processed, from the size of the area which is being worked, from the number of units that are going through in a particular period of time, or from other limitations that there may be on the application. We can work out what the right capture velocity is going to be, what air velocity we're going to need to ensure that we can capture reliably capture the material that's coming off, and also that we've got the right sort of filtration system and the right size of filters to have a reasonable working life for the system as well. So it's going to be something that will do the job and will operate under the conditions that the customer requires.
What does a typical extraction system from BOFA look like for the laser sector?
Well, for the laser sector, we typically offer what we refer to as a portable extraction solution. So our fume extractor itself is a standalone unit, which would typically be installed fairly close to the laser process itself. And inside that unit, we have a pump, which is an electrically driven pump, which will draw the fume through the filtration system. And the filtration package itself inside there consists of a 3-stage filtration operation, which is a pre-filter to capture dust and solid particulate and droplets that may be in the fume. We then have a HEPA filter, which is a high efficiency particulate air filter, which is a much finer degree of filtration to capture those much smaller particles, and generally referred to as nanoparticles. So these are particles which typically can pass through a standard mesh type filter, but they are still capable of being breathed in by a human being and can potentially be hazardous. So we've got to make sure we capture those to provide air which can be breathable. And then finally, we have an activated carbon filter, which is a gas filter. So this is a bed of activated carbon through which the final stage of filtration of filtered air passes, and this carbon bed absorbs chemicals from that airstream to ensure that any chemical compounds do not remain in the airstream, which goes out in the exhaust of the extractor. So the net effect of this is that we're drawing in chemically laden, dusty, particulate air, and we're passing out clean air, so that we are providing clean air back into the working environment. And that's the extractor itself. So for a laser application, depending on what sort of laser process we're drawing from, we'd either have a hose kit and a nozzle arrangement, which would be fixed in place near to, or as close as we can to, the laser operation itself. So, for example, on a production line where we might be producing cans of drink or something like that, and the laser is marking a batch code or a best before date onto the can, we'd have a nozzle close to the point where that laser is marking the can to make sure that we're capturing any little tiny fragments of material which are coming off. Or on a self-contained laser cutter or laser engraver unit, this may be a hose which connects directly to an outlet on that laser unit. So if there is an enclosure around an existing enclosure around the laser itself, then we would plug straight into that with a hose and coupling kit. And what we tend to do is we tend to work very closely with the laser manufacturers to make sure that we're providing both the right size of extractor and the right type of extractor with the right type of filters for the materials that the customer is processing, and also the right connection kit so that it's a very simple fit and forget option for the customer.
I understand that fibre lasers have seen some significant growth over recent years, and I guess that's because they're faster and potentially more accurate, but I guess they also generate significant heat. So how do manufacturers take account of that heat, and how can BOFA help maintain an operating environment that is optimal?
Well, fibre lasers are becoming more and more popular, and they're taking over from CO2 options in certain applications, and it depends on the individual process or the laser manufacturer as to what they would recommend for a particular product. And there's lots of different rules of thumb and lots of different decisions that can be made to choose the actual type of laser technology that you're using. But as far as BOFA is concerned, we're very aware of the needs of our customers, our OEM customers on these in these instances, and so we've had a lot of conversations with them about the particular needs of fibre lasers, and if there's anything anything different that we need to do. And the key thing appears to be, as you say, it's cooling and temperature control. And so we have cooling units which we now provide to actually cool the laser head itself to make sure it is remaining within the operational spec for optimum performance. Because the whole or one of the main advantages of a fibre laser is its speed of operation and its ability to maintain a very high rate of operation, which enables it to basically fire more codes per second than other types of other technologies, and it needs to stay within its operating temperature in order to do that. So it's very important in order to harness the advantages of the fibre laser, it's very important to keep it within its working temperature range. And we've got cooling units that can do that. We've got units like the 8200 and the 8350 cooling units, which will do that. And in more extreme cases, we also have air-conditioned units. We have the temperature control unit, the TCU, which provides an air-conditioned flow of filtered air to the laser control cabinet and the laser head itself, to allow very high speed operation in high ambient environments. So in parts of the world that may have very high ambient temperatures, or in very busy production lines where there may be a high ambient in the building, the TCU can be a vital tool in keeping the laser running at optimum speed. And optimum speed means optimum production rate. So an increase from 120,000 codes to 150,000 codes is a significant increase if it means that the production rate can increase accordingly as well. If the laser marking or the marking position is the pinch point in the speed of the production line, then it's very important to get that running as fast as possible.
Now, earlier you mentioned customization, so let's dive a little deeper into that. Could you give me a few examples of laser applications that would perhaps surprise our listeners, and talk about the role that extraction plays in those?
Yeah, sure. I think I mentioned the fashion industry and laser marking of materials like denim earlier. That's something that's becoming more and more popular to create a stone washed effect using a laser rather than the stone washing, and that's something which saves something like 90% of the water that is usually used to produce a stone washed product. But we get lots of applications coming our way. We get lots of inquiries coming our way for different applications. Some of the things that come to mind recently are the marking of food products directly onto the surface of the product. So we've had inquiries for laser marking of fruit, where codes or branding codes can be applied to a banana or an orange or any other fruit. That's quite an interesting one. I think that tends to be something which is more of a gimmicky thing than any particular use. But an awful lot of these applications start life as something which we look at and think, wow, how can that possibly be something that a consumer would want? But then it becomes the norm. We just get lots of inquiries for marking of different product surfaces. So lots of different product surfaces like the aluminium cans, like plastic labels, and even directly onto glass bottles. Glass marking is something which is a very key application.
We're in an increasingly digital manufacturing era. So how can BOFA's portable systems fit into a laser environment that is increasingly Industry 4.0 enabled?
This is a very interesting question, and it's something we've been looking at for some time. We've been looking at it from the sidelines, if you like. It's definitely the way that the market is moving. It's definitely the way that the industry is moving in general, and it's all about the connectivity of all elements of a production process. So we know already that it's extremely important for the maintenance schedule of an extractor to be integrated into the production schedule of the line on which it's working. And we've done an awful lot of work on that kind of functionality with our IQ controller. The IQ controller won the Queen's Award for industry when it was launched. And was a real step change in terms of what customers were able to do in terms of predictive maintenance and predicting when filter changes would be required, or picking up on any other operational issues for a unit working 24/7.
It sounds like there's a lot of innovation underway at BOFA, Geoff, and there's a lot more still to come. But for now, many thanks indeed for your expert insights.
Thanks, Phil. Thanks for your time.
Thanks for listening. If you want to find out more about BOFA and the benefits of filtration and fume extraction, visit bofainternational.com, where you'll find lots of sector-specific information. You can also catch up on all our podcast content by visiting bofainternational.com/podcast.